Hello students, I am Rohini Guri, lecturer in physics in RLS PU College, Belgavi. Today I am going to explain you how to determine figure of merit of a galvanometer. You can see aim of our experiment is determination of resistance of a given galvanometer by half deflection method and to find its figure of merit. So the apparatus used in this experiment are one battery, that is battery eliminator we are using, two variable resistance boxes, one is high resistance box and the other is small resistance box, two one-way plug keys we are using, and a galvanometer whose resistance and figure of merit is to be determined. Now we'll see the circuit connection. According to this circuit diagram, already I have made the connections and we can just check it. You can see battery positive is connected to galvanometer and the same wire is connected to shunt resistance or small resistance box ES. The other end of ES is connected to plug key K2. The second terminal of K2 is connected to galvanometer. Then the same wire from galvanometer is connected to K1. Other end of K1 is connected to resistance box, that is in series. Then resistance box to battery negative. So here you can see that if I just close this shunt resistance and plug key, all these are connected in series. This small resistance box ES is connected in parallel with the galvanometer. So this acts as a shunt resistance. Now we'll understand how to take the readings and how to record them in the tabular column. You can see in the tabular column we are going to note down resistance value, that is high resistance value, then corresponding deflection theta in the galvanometer, then shunt resistance value which is adjusted for the half deflection value. Now we'll start with the experiment. So first I'll switch on the battery, then before closing the plug key K1, I'll adjust some value of resistance. Say I am adjusting 5000 ohms. You can see this I am calling it as high resistance box because the value of resistance is up to 10,000, and this is a small resistance box and you can see the value is up to 100 ohms. Fine. So now I have adjusted here 5000 ohms of resistance. Now I'll close the plug key K1. In the first part, we are closing only plug key K1 and K2 should be kept open. The deflection in the galvanometer, now it is 26 division. Here we have to adjust the resistance value, high resistance value, so that we get even deflection in the galvanometer. If we get say deflection like 25 or 27 division, then we have to adjust the resistance value in the high resistance box, say another 100 ohms or 200 ohms we can adjust so that we get even division. It is not necessary that we should get only 26, 24. We can get 20 division, 18, 16 anyhow. But we have to adjust for even division deflection so that easily we can adjust half of that deflection. So now the deflection is 26 division. This I am going to write down here. So resistance value is 5000 ohms. Deflection in the galvanometer is 26 division. Then I'll close the plug key K2. Immediately we can see that the deflection in the galvanometer becomes 0. Now I'll adjust the value of resistance in the small resistance box. Suppose I am opening here 50 ohms of resistance. Now the deflection in the galvanometer is 10 division. Fine. So now I want actually 13 division deflection. So I'll adjust here another value, that is 20 ohms I am adjusting. So now the deflection you can see it is a 13 division deflection. So which is half of the earlier deflection. Earlier is 26, now I am getting 13. So the value of resistance which I have adjusted in the shunt resistance box that I have to write in the tabular column, which is 70 ohms, because all these keys are connected in series. So 50 plus 20 is 70 ohms. This is the value of S. Now I have to substitute the value of R and S value so that I can calculate G. What is G? G is nothing but resistance of the given galvanometer. So G is resistance of the galvanometer. If you substitute and calculate the value of G, again we are going to get the value of G nearly same as S. So that calculation I will show you again. So now if we want to take the next reading, again open the plug key K2, close these two keys which you had adjusted to get half deflection. So now K2 is open, again K1 is closed. So now I will adjust the value of resistance again, say 1000 more. Okay, 2000 I have adjusted. Now the value of deflection in the galvanometer is 20 division. So this is how we are going to continue. So here 7000 is the value of R, 20 division is the deflection. Again note here, close K2, adjust the value of shunt resistance so that you get a half, that is 10 division. Again if I try, you can see the deflection in the galvanometer is something like 7 division. Again I will open the resistance in the galvanometer. Now it is showing you 10th division. So it is half of 20th division. You can see the resistance adjusted in the galvanometer, in the resistance box, is again 70 ohms. So in this way the value of resistance will remain constant. If not constant, maybe plus or minus 5 ohms is possible, not much difference. So in this way we are going to note down the readings by adjusting for different values of high resistance, then corresponding deflections we are going to note down. By closing K2, we are adjusting shunt resistance till we get half of that deflection. Now we will substitute the values and we will calculate the value of G and figure of merit K. So now after substituting the value of R and S, first we have calculated here G value. As you can see, the value of S was 70 and after the calculation the value of G is 70.99 ohms. And for the second trial again, there also S value was 70 and now I am getting it as 70.70 ohms. Similarly, by substituting the value of G in the formula of K, K formula is already given, which is equal to E divided by R plus G into theta. What is E? E is EMF of the battery. So here we are using EMF of 2 volts and R value for first reading is 5000 and for the second it is 7000. Corresponding the same values I have substituted and I have shown here in the calculation. So you can see after the substitution, 2 divided by 5000 plus corresponding value of G value. For the first trial it is 70.99 into the deflection was 26 division. With that the calculation answer is 0.40151. After shifting the digits, I have shifted here 6 digits, 1, 2, 3, 4, 5, 6. So it is 15.1 into 10 raised to minus 6 ampere per division. Similarly, for the second trial, the value of K is found to be 14.1 into 10 raised to minus 6 ampere per division. In this way, by taking 3 readings and finally, we are going to take the value of mean value of G and mean value of K. The mean value of G indicates resistance of the galvanometer and mean value of K gives us the figure of merit of a given galvanometer. Thank you.